Okay, good morning, guys. Let me see if I can give you some chat privileges. Let me ask you if you guys have any questions so far. You guys can either click on the talk button if you have a microphone, or just type it in the chat window. Okay, well, if there's no questions, but anyway, if a question pops up, just keep typing it in, or just press the talk button. What is our textbook? Well, you have to look at the syllabus. It's in the syllabus, okay? Okay, so right now, this week, we are going to be on Chapter 1B, which is still thinking about, or still teaching you how to design code. So you don't jump right into coding. Okay, so if we cannot solve a problem in our head or on a piece of paper, you're not going to be able to solve it with a program. And that's where this chapter is basically focusing on. Okay, so this is the second additional chapter in the book from the Pharaoh book, and after that we're going back to the Amalek book. After 1B, we're going to start the regular chapters in chapter 2. Okay. Now, at the end of the next week, you guys have to take the first exam. So make sure that you've taken all the review quizzes, and you're keeping up with the chapters. Okay. So we need to talk about structured programming. So this is what's going to set you aside from somebody that is self-taught programmer, or somebody that watches a lot of YouTube videos and learn how to code. Okay, the reason that you are taking a degree, and hopefully you're going to a 4-year college, is because you don't want to be a coder. You want to be a designer who also knows how to code. So computer science is about problem solving. So problem solving using code requires you to have a very good understanding the proper design of a program and proper design of coding. So we need to look at the 3 basic structures of codes and understand when we are in a loop, when you are iterate through the same statements in a code, in the program, we need to prime the input, and we'll talk about what that means. So why do we need the structure? It is because that is the right way of writing the code. It's kind of like the building inspection, right? Why does the electrician have to run the wires in a certain way and install the electrical outlets in a particular places? You could plug in your appliances either way, even if the wires would be hanging outside the wall. And why does the building inspection has to take place before you can move into your house? Well, because there's a right way of doing things and there's a wrong way of doing things. So we need to look at the structure. What is the proper way? What is the right way? So recognize the structure and structure unstructured logic is what's going to be your basically your homework assignment. That you're going to have a bad code, but the code is represented in flowchart, and based on that flowchart, you have to restructure the code and make it a structured code. And we need to understand how that that's going to be done. So a spaghetti code is really difficult to alter, and that is the basic idea about structured code, that if it is not structured properly, it might work. It might work today, but when you need to modify it, we are humans, so we're going to make mistakes anyway. It's very rare that you're going to write a code that works properly the first time, and after you put it in production, it's going to perform the way you expected it. So you have to modify it. And if you build it wrong, then it's going to be really difficult to modify it. It's going to be very time consuming, and it's going to be very expensive. So that's why it's shortened the lifespan of that structured code, or shorter than a structured code, because it is so bad that when you try to modify it and try to fix it, you give up and you rewrite the whole code in a structured way, because it just doesn't make sense. So a spaghetti code is called unstructured programs. So think about a spaghetti code like if you put a fork in a bowl of pasta. When you pull out the fork, the strings of the pasta need to fall off that fork. And that's what you need to do when you are writing the code. It has to be flowing down from the top to the bottom, nice and smooth, and not tangled. So structure is a basic unit of programming logic, which is sequence, selection, and loop. One can diagram each structure with a specific configuration of flowchart symbols. So this book is basically telling you what structured programming is and all the basic shapes. So sequence. The sequence is one follows the other. There is no way that any one of the sequential statements or sequential stops can be skipped. So as you can see, the directional line also show the direction of execution. So you have a box, and that box is, okay, so let's say this is A, this is B, and this is C. So A has to execute before B is executed, and B has to execute before C is executed. Beside that, A needs to complete execution before B starts the execution, and B needs to stop or complete the execution before C starts the execution. And A happens before B, B happens before C. There is no way that you can have a program where you can skip either A, B, or C. So it's one after the other. It's kind of like you have to find a college. That would be block A. After you find the college, you decide what degree plan you're going to be following. So that's going to be B. And after you pick the degree plan, then you decide what courses you take. So that's going to be C. So first you pick the college, then the degree, and then the courses. So right now we're just talking about this really concepts. But first you kind of have to visualize what goes on in the code in a conceptual way in order to start writing the code. So you have to design it. You don't just say, I want to write the code. I want to write the program and open up the IDE and start writing the actual syntax. It's never going to work. it's going to take a lot longer time. Okay, so basically, if we look at different programming styles, okay, there are different shapes. So some people look something like this. Okay, so they spend very little time on design. Because they did not spend enough time on the design, when they code, it takes a lot longer because you make a lot of mistakes, the flow is not going to be proper, it's not going to be structured code. And the last step is testing the code. They don't spend enough time to test it. So that's where you see applications that are not well designed, coded for a long time, so it might be expensive, but it's not very well tested. So as soon as you buy the product, you have to update it because it's already had bugs in it. So what would be the right shape? The right shape would be something like this. Okay? When you have the design, when you talk about the structure of the code, like we are doing right now, because you have the right design, you have the blueprint. Now somebody can actually build it, so they can code it. Because there is a blueprint that's debugged and properly designed, coding will take a lot less time. And to find any kind of a coding mistakes, we will have to test the final product to make sure that there is no logical errors. So testing might take a little bit longer than actually coding it, okay? But not as much as actually designing it. Okay. So let's see. So the second structure is selection. So what is selection? Selection, you have an alternative. You have two-way selection. You're either going to go left or you're going to go right. The diamond shape is going to show you that you have to make a decision. So that's going to be the logical decision shape. Every time you ask a question, and that question can have yes or no answer to it, you use a diamond shape. Now here, when you look at it, if you see this block is A, and this other block is B. Now you can see, based on the logic, the question right here in the diamond shape, you either execute A or you execute B, but you're never going to execute A and B. So in this case, either or you're going to be executing, but not both of them. So it's not like the same thing like the selection. I mean the sequence was. In the selection structure, you either execute A or B. So in this case, you decided to take, or you have to take courses for your degree plan, right? But you have choices. You want to take a 3-credit-hour course or you want to take a 4-credit-hour course. And that's when you can ask a question, which one do I really have to take? And then you're going to take either the A track or you take the B track. So why is this important for us? Now that's going to be very important for us because when we write this code, and remember at the end of writing the code, we also have to test it. So that's going to be one of those important structures. So if I'm only testing B, okay, I wrote this code and I'm only testing B, and it doesn't matter if I type in 100 different values, and the logic only branches toward B, and I never test A, then at the end I have no clue if A ever going to work. So if you decide that you're going to take a 4-credit-hour course, and you're only going to consider 4 credit hour courses. You're never even going to consider 3 credit hour courses. How would you even know if you implemented the other side of your selection structure? So it's going to be very important to understand how the program is flowing. And right now you might think that, well, it's not that bad. It's not that bad right now, but later on, the structure is going to get a lot more complex. So we need to understand the basics before we jump to anything higher level. So when we have a selection structure, we have an else clause. So we have if something happens, then I do something else, I do something else. Okay, so that would be a pseudocode. That's how you would word it in a pseudocode. If hours worked are more than 40, right? So in that case, you have a diamond shape. Within the diamond shape, you say if, let's say, hours worked greater than 40. Is it true or is it false? Now we do calculation. Calculation is a rectangle. Okay, if it is true, then we calculate the overtime, and if it's false, then you just get the regular pay. And then we continue on with the code. Okay? So we did something before this question. So we show the arrow, and the arrow shows the flow of the code. Then we have the question, and the question branches the code in 2 different ways. And then we do either or calculation, but we're never going to do both of the calculations. Now sometimes we have a selection structure that we only do one thing if the if clause is true. And that's all we are testing. So if employee belongs to the dental plan, then deduct $40 from the gross pay. But there is no else statement. You either belong to the dental plan or you're not. If you belong to the dental plan, you're going to get $40 deduction. Else, just continue on. So in this case, this is going to be kind of like the shape of a diamond shape. Okay. We have the question, if dental plan, if it's true, then we do the calculation. The calculation is a deduction, and if it's false, just continue on. So don't do anything as far as the process is concerned. Okay. So this is the one-way selection. One-way selection means that you only do one thing if the statement is true, otherwise you just continue on. Okay. And the third structure is the loop structure. And in the loop structure, you are iterating through the statement. So you have a statement, let's say A. You have to take a course until you get an A in the course. Or you might have to take the chapter review quizzes until you get 85% or above. So A would represent that step. The A would represent those statements that help you accomplish the chapter reviews. But then the loop structure allows you to take it over and over and over again until you get to a certain level. So you are redoing, you are repeating the same steps over and over again. So this is different now from the selection statements or from the sequential statements. So loop structure is interesting because you need to decide how to get into the loop. You get into the loop with a kind of a same logic, like you went into the loop with the selection statement. But how do we get out? With the selection statement, that wasn't the question. We could get out as soon as either the A block or the B block completed, we get out and we continue on with the program, with the code. Now here with the loop, if you don't design properly how to get out or when to get out of the loop, you might be in an infinite loop and your program will never finish. So that's going to be a different challenge to deal with when you deal with loops. So with these three basic structures, you can build any program, any application, any operating system. When you analyze any code, the code either going to be sequential, selection, or loop. And that's all the options. So how can we build complex applications with these three basic structures? Well, we can combine these structures. The structures do not lose their identity. They're still going to be the same basic structures, but they can nest other structures inside. So they can have other structures inside of them. So this is a very good example, and make sure that you guys understand this and ask questions about it, or really look at these examples and analyze them and make sure that you do understand them. So the left side is the flow chart. The right side is how you would write the pseudocode. And remember, right now you guys have to do both of them. So in this case, if you look at this example and you take the 10,000 feet view of this, you can see that this is a block and this is another block. So you can say this, let's say this is C block, and then we have D block. So that's just 4 blocks, one after the other. They're going to be executing. So A, B, then C, and then D. Remember, you are at 10,000 feet view. And then you start zooming in. And as you zoom in, then you look at the structure inside of C. And inside of that block C, there is really a selection. And now we have a condition, and either E or D is executing. And then you look inside D, and then you see that D has a structure inside of it, and in this case it's just going to be a loop. We have a condition, we have a repeating step G that depends on the condition, repeats over and over and over again until the condition returns false, and then we continue on. Okay, so let's see if we can give some example of this. So let's say you wake up in the morning, right? And so you wake up and then you dress up, okay? And then you have a condition, and you say, okay, do I have time for breakfast? And then it's either going to be, the answer going to be either yes or no. So if there is a yes, then go ahead and eat breakfast. So step B would be eating breakfast. If you do not have time to eat breakfast, then it would take over with step E, and E would be pack something dry or something easy to eat, so you can eat it in your car or on the bus. And at that point, you get down to the D structure. So you woke up, you dressed up, you have some kind of a breakfast. Either you ate breakfast or you're carrying the breakfast with you. And now you are in the next stage. And in that stage, let's say you are, let me see if I can come up with something. Okay, let's say you're leaving your house and you need to lock the door, all right? So you turn the key and then you open the door handle and the door still opens. So then you close the door and then you turn the key again and then you try the door again and see if it's locked. It still is not locked. Okay, so maybe you're turning the key the wrong direction. So you keep pulling the door shut, turning the key, testing the door if it's locked or not. Okay, until you find out that the door is locked. And then you keep moving on. And in this particular flow chart, we don't know if you're going to take a bus, you're going to take a car, is somebody going to give you a ride, or you're going to ride your bicycle. The arrow shows that we're done with this code up to this point, but you have to consider only these 4 stages. And here you have really 4 steps in your sequence, where C is a selection and D is a loop. So even if you have a one-way selection, again, look at it from a 10,000 feet view. Okay, from a 10,000 feet view, this right here is, let's just call it A, and that's going to be your step A. So you have a condition, and within that condition, you're either going to be yes, the answer is going to be yes or no. If it's yes, we have multiple steps, but those multiple steps are really just sequential steps. So step J, K, and L, those are sequential. And the sequential steps are inside a one-way selection. So how do we know it's a one-way selection? Because no has nothing in it. So if the condition is no, then we just move on. Okay. So let's connect it to the previous example. So let's say you did lock your door finally, and now you are deciding how you're going to go to school. And you're going to say, am I taking a bus or not? Okay. So if you are taking the bus, if that is true, okay, then maybe you have to figure out where the bus stop is. That would be step J. You might have to look up what is the schedule for the bus. That would be step K. And then actually walk to the back bus stop. That would be step L. If no, you just go on, and you might have another question later on. If I have a car, or if I have a driver's license, or if I have enough gas in my car to even drive my car to school. So in this point, you're just considering if I'm taking the bus, then what do I need to consider? Okay, and look at the pseudocode. You see the indentation? Make sure that you understand the indentation. When a structure or multiple steps belongs to another structure, like in this case, the structure starts at the condition and ends when the structure is done. You can see that with the if statement and the end if shows where the structure starts and stops. And because the condition is true, then we execute J, K, and L in order. So as we are combining structures, again, look at it again, 10,000 feet view, right? What do we have here? We just have 1, 2, and 3 structures. It's a one-way selection, right? We only execute something when the condition H is yes. So you have step J, and then you have a loop structure. When the loop structure exits, then you have step L. The 1, 2, and 3 is really just a sequential structure. So when you zoom in into a step 2, in step 2, you realize that it is a loop structure. So as you can see, when you look at the if statement, again, it starts right here and ends when all the lines are come together again. So we have if statement, and then we have the end if statement. Everything is indented until you see the while and the end while, and that is also indented. So you can see where the if statement starts, and within the if statement you have the sequential 3 steps, out of which one of them is a loop. So what belongs to the loop, which is step n, is indented within the while and end while. So indentation is very, very crucial. Okay. So again, what do we see here? All of this becomes the second step now. So this is 1, 2, and then we have 3. So still a 3-step process. The step number 2 is now more complex. So when you look inside step number 2, so you were at 10,000 feet, now you're at 5,000 feet, looking inside number 2. Now within number 2, you realize that you have a 2-way selection, but at 5,000 feet view, you only see it as a block. Let's call it 4. And then you go down to 2,000 feet. At 2,000 feet, you realize that it is a selection statement, a 2-way selection, where either Q or P is going to be executed. So you can see that. So the if statement starts. You have the first step, you have the third step, and the while statement is at the same level with the first and the second, the first and the third step. Now within the while loop, we have the 2-way selection. So the 2-way selection is indented in the while loop. Now because you have the true statement and the false statement, those are indented within the true statement side of the if statement, of the selection statement, or on the false side. So step Q is indented in the else clause, and step P is indented in the if clause. So if clause is the true side of the condition. Indentation is very crucial when you're writing a pseudocode. It might not be as important when you later on you're going to actually write the code, but some languages also require you to have indentation. So like Python requires you to have proper indentation. So right now we just need to learn this basic structuring, but what you need to understand at this point is indentation matters. Okay, even if you know how to program in other languages, but you know indentation doesn't matter. Okay, even if it doesn't matter, is not enforced by the programming language, we still do indentation because the code is easier to read and easier to interpret. Okay. So here's your summary. This is the basic information in this chapter. You need to understand this and maybe look at the way that you make decisions every day. Okay, so that's going to be part of your homework assignment to basically write down what do you do in the morning. Okay? And that's what you do in any STEM field or any engineering courses or engineering degree plan. You have to write a flow of processes and make decisions based on that. So it's going to be very, very important for you to develop this skill set. You have to do all the exercises in the book, in the chapter, in order for this to really make sense. I mean, we can talk about this all day long, if you don't do the exercises in the book, then it's not going to make sense. And later on, when you start coding and the codes get a little bit more complicated, you're going to get frustrated because it's not going to make sense. So this is very crucial to understand. Okay. So why isn't this not structured? Well, this is not structured because if you look at the shape, right? So what is we can see that there is a logical decision to make, and the arrow points back above the logical decision, which is the diamond shape. So what is the basic structure in order to analyze this? The basic structure is this. All right. So this is our basic structure. We make a decision, then we do something, and then we back directly. Now, some people are going to write this right above the loop or the logical statement, but there is nothing between the arrow when it points back to the right above the diamond shape and the diamond shape. There's no shapes between the arrow and the diamond. So where is the problem? The problem right here is right this. This is wrong because that is not that makes this code not structured. Now, some of you who programmed before, right? You might write code like this, and you say, "I do this all the time," and that is possible. I mean, the code will work. It's just they're not going to be structured. So what you should do is have, basically we need to prime. So this is going to be the primer. Okay. We connect the shape back right above the EOF, and then we make a duplicate. We make the duplicate of the input. So this is where you're going to, again, ask for the original number. So we ask for an original number, and then we're going to make decision based on that original number. We're going to output the answer, and then we go back and ask for another original number. So in this case, if we call this the A block, then we moved the A block. Right? So this A block becomes the priming value. Okay? This is the priming read value, and this one becomes the update inside the loop. And now that is structured. So here we actually gave another A up here. So A, decision within the loop, more A's to update. Okay. So this is a structured but non-functional flowchart. Okay. So the problem here is there's an input, and based on the input we make a decision. Okay. We only have the output. So what's missing is the update, where we need to update the new value. Otherwise, it's never going to accept because we never changed the original number. So we needed, in this case, we needed another shape, and that is a parallelogram. Parallelogram shape is input and output. Okay. So now you can see that we have the priming value, and then all the subsequent inputs are coming in that parallelogram at the end of the loop, and we call that the update, where we are updating the value on which we make the decision. So why do we need structured programming? For clarity, professionalism, efficiency, We also need to look at the maintenance, and we have to look at the modularity. Okay, so what does that mean? Later on, when you look at this, okay, and later on when we learn object-oriented programming, okay, you might see that step number 2. See that step number 2 is a really complex structure, or getting into a complex structure. Okay, we can build a module out of that, and we'll learn in this class how to modularize programs later on to make the program easier to read. Okay. So what's wrong with this? You really need to look at this and say, okay, why is this not structured? So you're going to see that a lot on the internet. You know, somebody taking programming classes, especially you guys on online courses, right? You are really good at Googling and searching for things. And sometimes even simple code, what I see that you guys turn in, that would be 2 minutes to read or 2 minutes to write, you just Google and probably look for that code for half an hour. Okay, there's no reason for that. It's, you know, you're not going to learn anything by Googling somebody else's code. But it's, for me, it's really obvious. It's really easy to see when somebody copied somebody else's code, especially code from the internet, where somebody is posting some solutions, and they are self-taught programmers, and they never understood or never learned what structured programming is, because they write code like this. But what is wrong with this right now? Again, you look at the 10,000 feet view and then 5,000, 2,000 feet view, right? So in this case, you might say that this whole block is, let's say, call it 1. Okay. So we have the G block, and then we have the 1 block. So 1 block follows the G block. And then we go down to 5,000 feet view, and in 5,000 feet, we see that we have a selection. Now, is it one-way or two-way selection? Well, I'm doing something when the when H is my condition. When H is evaluating the question, I'm doing something when I'm on the no side, and I'm doing something when I'm on the yes side. So that's fine. Okay. The problem is that when there's an I condition is also a conditional statement. It is a selection structure, and the selection structure doing something with J, and then doing something with K if it's evaluated to yes. Now here, J is the biggest problem, because J is shared between the H and the I groups, or the H selection and the I selection. That is not structured. That is not structured. So what do we need to do? We need to get rid of this line. Okay. Okay. So we need to get rid of this line right here. We don't need that line. And when we are on the no side, we need to add another J. Okay, and then connect it back to the program. So now you can see if H is evaluated, if H is no, J executes. If H is yes, then this block executes, separate block. Now when I is evaluated, if I is no, J is executed. If I is yes, then K is executed. Now there are two separate entities. So it is much better, and it's a J1 and J2 is exactly the same. Okay. So let me see if I can. So these are not two J's; those are exactly the same J's. Let me see if you if I can give some kind of example. So let's say H is a school and I is a school, and H is a C++ class. Okay. So if you are, let's say, in H is a university, okay, and the university requires you to take a C++ class, okay, but the university charges you, let's say, $50, or let's be more realistic, $500 for a C++ class. Now, if I is a community college and you have the exact same C++ class, you do not want to connect to J and charge somebody $500. Okay? You want to have your own J. Your own J means you're still charging for a C++ class, but here you're only charging, let's say, $100. So J can represent the charge for a C++ class, but they are at two different institutions. So you do not want to make a decision saying, no, I have not taken C++ class, so I have to sign up for that. And it doesn't matter if it's at university or community college, I'm going to take the same C++ class. I'm going to pay the exact same amount. Right? Because sometimes you can see that at the university level, community college level, you're taking a C++ class using the exact same book. So that means same contents. But one charges more, one charges less. So J is J. They're exactly the same, but we make a copy of that and be using its own copy. So we don't share these blocks of code between different structures. We need to make sure that these structures stay separate. Okay. Does that make sense? Okay. So you break it down into steps, right? The way that you are looking at a code is one step at a time, and that's where I'm trying to get to when I'm talking about 10,000 feet view and 5,000, 2,000 feet view, right? So in this particular case, the book that steps you through, look at G first, and then after G, the second step, you're looking at G is followed by H. H is a condition. Now, what happens when there is a condition? Condition is either one-way selection or two-way selections. Okay, so we have one way we are doing J. On the other way, what do we do? Well, it's a more complex issue. So there's another selection. So within that selection, you go down and follow down the left side and the right side. And you make sure that you cannot share any shapes between those selection statements. Okay? So that's why you break the line on the I condition on the no side, and you make a copy of J. And this way the code does exactly the same thing what it was doing before, but now you have your own copies of J. So now if somebody decides that they're going to charge you for, let's say, lab fees, right? The university can put another block right here. And because the university decided to charge you more for a course, it's not going to affect you, because you have your own J path. So within the community college, the I structure, you can put in maybe give you discount, or hopefully by next year or so, community college going to be free for everybody, right? So so those kind of things that separation going to be later on much better because you can maintain the code, you can add to the code, you can remove from the code, and you only have to focus on one particular area and not the whole code and how the whole code going to be affected. Okay, so in the original way, when you updated the original shape, when you updated J, maybe you updated J in relationship to H, but you might have not known that I was also affected by those changes, and that's when you're going to see a lot of problems. Okay, so separate the shapes, make sure that it is not a spaghetti code. So the left side would have been that spaghetti code. The right side is not structured. Structured because you have the spaghetti flowing down, and there is no crossing of the spaghetti strings within those shapes. Okay. So now you just restructured something that was unstructured. Okay. Now this is a very important chart. If you don't want to read the whole book, right, or you just want to see if you understand this whole concept, okay, cover the right side of the page and write the pseudocode based on looking at the flow chart, and then use the right side to double check if you did it correctly, and then do it backwards, right? Cover the left side of the page and just looking at the pseudocode, can you recreate the flow chart based on that? Okay, so if you can do that, then you understand this chapter. This is probably the most important slide in the slide deck right now in order to see if you understand chapter 1B or not. Okay, but this is very important, and make sure that you do not skip this slide and you practice it on a piece of paper. But that's pretty much it. That's what this chapter is about. So you just have to remember you have sequence, selection, and loop. Understand the shapes of those, and understand the pseudocode for all of that. Those kind of shapes, right? So all problems can be reduced to a combination of these three shapes, basic shapes. We can analyze any program and eventually come up with these three basic shapes. Doesn't matter how complex it is. Okay. So structures attach to each other only at the entry or exit points. So even if you combine these structures, you have entry and exit points, and that's how they attach to each other. And that's why they don't overlap. Okay, and in our last example, that was the problem. J was overlapping between two structures. It wasn't a combined shape. It was an overlapping shape, and that is not allowed. Priming input is important when you have loops. And it is up to you to look professional when you write code. And this is the first step of learning it the right way. And if you programmed before and you haven't heard of structured programming, you're going to have a hard time changing how you look at code, because you're probably not writing structured code. So this is a little bit more challenging to those that actually programmed before. If you haven't programmed before, this is going to be the only way how you learn how to code, how to program. So you're going to have an easier time because you're going to learn it the right way from the beginning. And one of the most important skills that you can pick up from computer science or from any programming course is to recognize unstructured logic and be able to fix when something is not structured. And just by analyzing the code itself, analyzing the structure of the code, you should be able to create a structured code out of it. And that is one of the very first essential skills somebody in a STEM field or in programming can learn, regardless of what language you're going to know later on or you know already. Okay, analyzing the code is pretty much what most of the people do these days. You rarely really create code from scratch. Most of the time you're modifying somebody else's code, but you need to know what to look for when you modify somebody's code. And this is the first step in understanding that kind of analysis and code design. But anyway, so like I said, make sure that you practice on this one chart right here and do it 4 or 5 times. Okay, so read through the chapter and then do this on a piece of paper. Like I said, cover the left side, do the right side. Cover the right side and come up with the left side. And if you're done with that, you're done with the chapter. So, so that would be the best way of practicing and learning. On the flowchart side, focus on the shapes. On the pseudocode side, mainly focus on the indentation. And how do you connect the flowchart shapes to the indentation on the pseudocode? I think that's where the most confusion comes from anybody starting to learn structured programming, I guess. Okay, so does anybody have any questions so far, or did I answer all the questions? I don't know anything about the textbooks, or what's different, what's the same. Okay, I'm talking about the content of chapters. Okay, we are, 2-3 weeks into the course. I'm not going to talk about what books we need and what material needed for this course. If you don't have that already, then it's way too late. You're way behind. Okay. Okay, so if there's no more questions, then make sure that you guys talk on the discussion board, help each other out, and keep up with the course material. Remember, next week you have 4 chapters to know, and so that means that you guys are going to have to go through the review quizzes to prepare for that test. That's going to be your best bet. And don't fall behind, okay? More you fall behind, or you're looking at, saving $2 on a book or something, it's going to hurt your final grade, and it's not worth it, okay? So make sure that you keep up with the schedule. Look at the syllabus. The syllabus has the outline, and read the chapters as it is outlined in the syllabus. Do the chapter quizzes, talk to each other, and I'll see you guys next time.